Welcome to Science Maker Lab CAD Lesson 2M, Preparing a File for Laser Cutting. I'm Nick.
And I'm Matea. We're two of the lab assistants here in the Science Maker Lab. Now that we've got our DXF file ready to cut and or engrave on the laser, we're going to need to import the DXF file into the RDWorks laser cutter software. Like the Cubicon 3D printer software, this is CAM, or Computer Aided Machining Software Package. It takes in a CAD file and outputs a series of instructions for the machine that makes the parts.
But what does import mean, and why a DXF? Exporting file is a way of saving the file into a digital code other than the file format used by the software that made the file. Importing a file is opening a file that is in one of these non-native formats. These file formats are like languages. They contain the same information, but use different words to describe that information. Importing and exporting is like going through an interpreter. The standard format for exchanging two-dimensional CAD files between different CAD software packages is DXF. This standard format DXF
Goes way back to 1982.
Ron used this format in the mid to late 1990s when people were laser cutting RC airplanes he designed, and we still use this format today, though likely a newer version of it.
Why don't we open RDWorks software and see what we get? The first thing we're going to notice when we look at the screen when we open it up is that the middle of the screen is taken up by a big rectangle with a bunch of evenly spaced dashed lines crisscrossing it. If we look along the rulers at the top left of this big rectangle, we can see that it measures 900 by 600 millimeters.
The laser cutter that we use is the TS6090,
which stands for 60 by 90 centimeters of bed size.
The rectangle represents a top view of the bed of the laser cutter.
Sometimes when we first use the software, the bed won't be 600 by 900. Smaller than this, and we can't use the whole bed. If it is set larger than the bed of our actual laser cutter, it could cause machine damage trying to move itself further than physically possible. So it's important this is set correctly.
To fix this, we go to the drop-downs at the top of the screen and we open the drop-down labeled Config S. Then we select Page Setting. At the top of the pop-up box that opens, we can set our page size to 900 by 600 millimeters.
While we've got that drop-down open, we can also adjust the colors of the lines and background and change the spacing of the dash grid lines if we want. Like the environmental settings in the Cubic Creator software, once set, this is something that we should never have to adjust again unless we download the RDWorks software onto a new computer or open it in a new user profile.
Now that we're sure things are set up properly for our machine, let's have a closer look at the layout area. When we import parts, we can position them on the screen and they will be cut or engraved exactly like they are previewed here.
The rest position or origin of the laser machine is at the upper right corner of the laser bed. This keeps the laser head out of the way when someone is loading or unloading sheet materials onto the actual cutting bed. Because of this, we just got some small pieces to cut. We usually place it near the upper right corner to minimize the time the laser spends traveling to and from the places where it's actually cutting or engraving.
Down in the lower left corner, we can see a big green square. This green square depicts the start point of our cut file. When we import parts with the default settings, this green square will move to the upper right corner of an imaginary rectangle that would just box in everything we want to cut or engrave. This is where the laser head will start from when cutting whatever we've laid out on our big rectangle in RDWorks. When we set the actual parts and file up on the laser, we'll manually assign this starting point to an XY position on the actual cutting bed.
So that's the virtual cutting bed in RDWorks. Next, let's look at the upper right of the RDWorks screen for an area that looks like a spreadsheet. We always leave this set to the tab labeled Work. We can choose to cut or engrave different entities differently, and this area helps us to manage that by keeping each different kind of cutting/engraving instruction in a different row. We can also use this area to control what order the cutting or engraving operations happen in. Considering that a part often falls right out of a sheet after being cut, this is important. If we cut it and then engrave it, there's no guarantee that the wood or plastic will be in the right place when the engraving starts.
To separate the entities so that we can control these operations individually or in groups, we assign entities that we want to laser differently to separate layers. The word layer dates right back to the late 1930s, from the world of animation. In animation, A series of pictures changes gradually so that when played back quickly, the human eye interprets these changes as a smooth motion. Disney made the movie Snow White. They departed from the usual practice of drawing separate pictures for each frame and used stacked layers of glass to paint different elements of the scene. In addition to creating the illusion of 3D depth, this also allowed them to edit each layer separately, so that if a character was walking along in front of a background, the background could be left in place and only the plates depicting the character's movement would need to be changed out. In hand-drawn technical drawings, the semi-transparent paper called vellum was often used and different amounts of detail could be added or subtracted from a drawing, simply by adding or removing drawings from the stack while the whole stack was backlit.
In CAD, there is no need to physically locate the drawing elements on different layers, but entities assigned to one layer can be displayed or not displayed, edited or selected without affecting the other layers. Each so-called layer is separately editable. This is analogous to our features in SolidWorks. In SolidWorks, we can edit one feature without affecting another. In RDWorks, this task is handled by using the old-school concept of layers. We can assign an entity to a layer by selecting it, and then selecting on one of the little square color boxes that run from left to right at the bottom of the screen. Each color will be assigned to a separate layer, and each layer will get a row in the little spreadsheet at the upper right corner. If we're designing in Design CAD 97, we can actually assign both layers and colors in Design CAD, and they will be carried over into RDWorks into the DXF file we export and import. This can save us a lot of time in our RDWorks, which is one of the reasons we actually really like using that quarter-century-old software.
At the bottom right is a sectioned off group of tools labeled LaserWork. This is the area that has the commands that control how the file is output once it is ready for the laser cutter. The only button we ever use is Saved to U file. This saves the instructions for the laser into an executable computer file. We usually place that directly onto a USB key that we then transfer to the files into the laser cutter computer memory. We don't hook it up directly to the computer because they're not in the same room and the laser needs to be directly watched when it runs, for reasons of safety.
Running up the left side of the screen, we have some basic drawing tools. The drawing tools include line, pointer, edit node, line with no midpoint, polygon or polygenic as RDWorks calls it, C-curve, box, ellipse or circle, text, and point. Text is the one that we will use the most. In fact, in many cases, it's better to add text in RDWorks than it is to add it during the CAD drawing. We've got some other tools towards the bottom. These tools include mirror horizontal and mirror vertical. These two can be useful, but we don't use the other tools found here much.
There are two horizontal toolboxes along the top. We'll start by looking at the bottom of these two. We don't use tools in the three right sectors of this toolbar, so we won't discuss them. Starting at the left, the X and Y indicate the position of the center of the parts laid out on the screen. The horizontal and vertical double-headed arrows indicate the magnitude of the extents of the drawing in the X and Y dimension. The percent controls our scale in X and Y, expressed as a percent. If the lock beside them is closed, they will work together. If it is unlocked, the selected entities can be scaled independently in the X and Y axes. The tic-tac-toe grid, beside the lock, controls the point that the part is scaled about. The circle with the arrowhead will rotate the selected entities by whatever degree value is typed into the box beside it. The process number box is not adjusted.
Moving to the left of the top toolbar, you will also see New, Open, Save, Import, Export, Undo, and Redo, which are all standard Windows commands, so we won't cover them here. To the right of them, you can find the view controls. You'll see Move, which pans the entire display window, Zoom out, Zoom in, Show Page, which fits the entire laser bed into view of window and centers it, View Data, which zooms in to show only the parts that are selected, View All, which zooms in to show all of the parts that are on the bed, and Show Select, which zooms into an area that the user drags a box around. Continuing to the right, you should see Show Path, which depicts the path that the laser head will take to go from its rest position to cut or engrave all the parts and return to its rest position. Edit Cut in Property, which we will not use. Edit Cut Property allows us to fine-tune the order of which the lines get cut in, which is not used by us. Curve Smooth makes curves smoother, and we can handle this in CAD before exporting. Bitmap handle, when a photo or engraving is selected, this opens a pop-up that allows tuning of the etching or engraving properties and appearance. Cut optimize, which we normally make sure that it is set to order of layer and inside to outside, and then leave it alone. Combine curve, which is also not used by us. Delete overlap will prevent double cutting of a line if our DXF has multiple lines in the same place. Generally, we can handle it in CAD, but it can save cutting time if we have a file with some double lines. Offset polygon, which is done in CAD. Data check will check for open contours, which is also done in CAD. Preview, this is a super useful tool. It will give you an animated preview of the cut process in real time or faster or slower than actual time. It also tells you how long a laser cut or engraving job will take before you try it on the actual laser cutter. And then there's group and ungroup, which allows you to set a group of entities to act as a single entity, like a sketch text entity, or separate them out again. Okay, so we've had a quick look at the workspace and the controls. Let's bring in a file and actually start doing some work. We can click on the import icon at the top left or click File Import. If you accidentally select Open, don't worry. You can simply set the file type to all, find your DXF, and it will import as normal. The default is the RLD file, which you would use to save your work if you were laying out parts to be cut and had to break away from it before you were done. It's the native file format for RDWorks files. We'll head into our folders and find the DXF we want to import and select it. The 2D part drawing will be imported and appear in the middle of the laser bed depicted on our screen. You'll notice that the green square will move to a position at the upper right of the file you imported. This is where the laser will start when you go to cut the file. It's the origin of the cut file. Just like in SolidWorks, we can zoom in or out by rolling the mouse wheel, and just like SolidWorks, depending on where the mouse pointer is, the drawing will pan as it zooms. We can use the scroll bars here to move the drawing back somewhere near the middle. We'll use the Show Page icon to center things perfectly. If we press the Escape key, the part will be deselected and will appear in whatever color it was imported in. Note that we now have data in one line in our spreadsheet section for each color of entities that we imported. Sometimes the part will appear to be all black, but we will have two different layers of black. This happens when the file was opened in DesignCAD and black lines were drawn in. The drawn lines will be fully black, where the unmodified lines will be very dark gray. We can reselect either individual entities by clicking on them, or group by dragging a box around them. Let's group select the entities we've brought in and move them up to the upper right corner. To move an entity or group, you place the pointer over the middle of the group parts until you get a four-way arrow, then click and drag. If we want to group them so we can select all the entities with a single click, we can use the group tool at the right of the uppermost toolbar. We want the part moved away from the center of the sheet so that if we add another file part, it won't wind up superimposed on this one. If that happens, it can be difficult to select them independently to separate the parts for cutting.
Now we'll import an image or photo. You'll notice it's imported in black and white, even if it was a color image. We'll resize it by dragging a corner. The first time we try to resize it, it will get very big, but it will work properly after that. We don't know why this happens. It's just a quirk in the software. Once it's small enough, we'll select the photo and then click on a color we haven't used before to set it in its own layer. We'll see a new layer appear in our layer control spreadsheet at the top right. We'll drag our little picture over so that it is superimposed on the part we want to cut out. If we want, we can use the grid lines to visually line things up. Now would be a good time to talk about our layer control spreadsheet. The first thing to notice is that each color is in its own row. This allows us to control the laser cut process in two ways. One, we can control the cut or engrave settings for each of these layers independently, and two, we can control the order in which they're cut. We'll start by setting up the order of operation. If we activate the Cut Optimize pop-up menu, we'll see at the top that there is a checkbox to enable or disable the setting order of the layer. We want this enabled. Once done, the laser cutter will perform the cut instructions one layer at a time in the order that the layers appear in our layer control spreadsheet.
We won't always import the various entities and layers in the order we want them to be cut in. To move them to the desired order, we can click on the line of interest in the spreadsheet and then select the up or down button below the spreadsheet to move them up or down in the queue. What order do we want the layers in, and why? Well, when we put a sheet of wood or plastic into the laser to be cut, it will either be held in place by its own weight or taped to the bed to hold it in place while we cut it. There's not much sense in having a precision of plus or minus 0.2 millimeters if the part we're cutting moves around while we're cutting it. But once we start cutting things out of this sheet, these parts can move around a bit. They can either shake around in the gaps created by the kerf. If very small, the parts may fall through the grating into the trap below. If very light, they may get blown out of position by the blow-off air that the laser uses to keep the lens cool, keep dust from piling up, and constantly blow away embers to prevent fires. To prevent those problems, we want to keep the outer portion of a part in place while the inner parts are engraved or cut. Thus, our order of cut is always etch/engrave, inside cuts, outer perimeter cut.
Now let's take a closer look at the cut instructions for a layer. To do this, we double-click on that row in our Layer Control Spreadsheet section. A pop-up appears with our layer parameters. This will be slightly different if the layer is being scanned, etch/engrave, versus being cut. The layer parameters for a cut are: Layer, displays the color of the layer being modified; is output, always leaves set to yes; speed, this will vary with the material being cut and the power level being used; if blowing, this translates to, do you want to blow off air to be activated? The answer is always yes. We will manually adjust the pressure of this air if needed. Processing mode, always cut for a laser cut. Power level, set laser 1 to 35 and 35%. Laser 2 is for a 2-tube machine, so just leave it disabled as it does nothing anyway. The rest of the controls are always just left at their default settings for our purposes. We'll accept our changes by clicking on the button that says OK. Note that it's not enough to press enter. You must click on the OK button or your changes will not be saved.
Now we'll double click on a scan layer in our spreadsheet at the upper right. The layer control pop-up will appear again, but this time the options in the bottom half will be different. We'll set layer, output, and if blowing, the same as before. Verify that the processing mode is set to scan. Speed should be set to between 40 and 300 millimeters a second, depending on what finish you want to achieve and what power settings you want to use for your etch or engrave. As a general rule, engraving takes place at the low end of this range, and etching takes place at the higher end of this range. Power. Again, only one laser is enabled. If etching, minimum and maximum are set the same. Power level for etching will be set between 14% over 14% and about 23% over 23%, depending on the material, speed, and darkness of dot desired.
If engraving, the power levels will be set across a range within the linear power output range of the laser tube. The tube puts out no laser beam below 13% power, then has a fairly linear increase in output power versus input power from 14% to about 22%. Above that, output power increases by less than the increase in input power. So, we tend to set a range of powers within the 14% to 22% range. In engrave mode, the laser will use the lowest power level for a white portion of an image and the highest power level for the black parts of an image. Thus, setting this power range is a way to adjust the contrast in depth of a cut between light and dark portions of an image. The checkboxes below the power settings are left unchecked unless engraving. To engrave, output direct must be enabled. Overstriking. Leave it set to unprocess.
Scan mode. X swing means the laser head will etch or engrave a horizontal line. Drop down to the next line and then etch it in the reverse direction with the engraving happening on the x-axis. This is the preferred method as it results in the least wear to the laser mechanism. However, Y swing can be used if, for example, the part has 2 columns of vertical lettering and the part can't be turned 90 degrees for cutting or engraving. In this case, Y swing will be much faster. We just avoid it if we can, as more mass has to move back and forth, creating more wear on the mechanics of the laser cutter. Unilateralism means that the laser scans a line, returns to its starting position, and then drops down and scans the next line in the same direction. This gives a very slight increase in the quality of the image produced, but it is much slower.
The next setting is the interval, or change in Y position between X scans when running in X swing mode. We generally leave this set to 0.08 mm. The laser beam is wider than this, so there is a bit of an overlap, but we found it gives smoother looking results than setting the interval to 0.1693 mm, which eliminates any overlap between the scan intervals. Power needs to be set lower if using a finer interval, because of the double cutting effect. Once you set the layer parameters for a given color layer, they'll remain at those settings for that color unless you change them. For scans and engraves, it usually takes a few trials to get the right settings. For the 4.7mm plywood we use for most teaching projects in the ScienceMaker lab, we use 12mm per second for cut speed and 35% power. To engrave lettering in it, we'll use the 250mm per second and between 15% and 20% power, depending on how dark and deep we want the lettering. Acrylic tends to engrave at about the same power settings as this plywood, and cuts at 35% power with a speed of 12mm per second for 3mm thick acrylic, 6mm per second for 6mm thick stock, and 2.5mm per second for 10mm thick material.
Think of the laser cutter like a sunburn machine. The slower it moves, the more time a particular part of the material will be exposed and the more it will get burned. The higher the power setting, the less time is needed to make the same burn. So, cut depth is inversely proportional to speed and directly proportional to power. These can be used to adjust darkness and contrast in a scan. You may have also noticed we cut almost everything at 35% power and then just adjust the speed for different thicknesses of materials. When cutting, too much power or too little speed is better than the other way around. You won't burn the part, as once the beam vaporizes a volume, there's nothing left for it to interact with to cause more heat. But if you undercut the part, unless you figure it out without moving the sheet on the table, it's usually going to wind up as scrap.
Moving on. In our drawing, let's select our photo that we want to etch and explore the bitmap handle tool. We can select the tool by either clicking on the icon in our top toolbar or by using the drop down and clicking on Handle, Bitmap Handle. A pop-up bitmap handle toolbox will appear. There is a preview window on the left, some dimensional and resolution information at the top right, and controls below that. Brightness and contrast work as they normally do. Below them is an option to invert the colors. Below this is a set output resolution. Enable this and set the output between 150 and 300 dpi. The laser can only produce about 150 at any rate. Higher settings simply result in overly large files that can take a long time to transfer and may even exceed the 1 MB size of the memory of the computer in the laser cutter.
The bottom right section is the dither controls. We will enable this and then select dot graphic for dot art etching of a photo or image, black and white for something where we don't want any gradients like lettering, grayscale, this is used when we want to engrave something. To preview the effects of your adjustments, click on the button that says Apply to View. The image in the preview window will adjust to reflect the changes you've made. When satisfied, click Apply to Source and then click OK. The image on your main screen will not change immediately, but will take on the new settings as soon as you click anywhere on the virtual cutting bed.
As mentioned earlier, getting a good etch or engrave is a bit of an art rather than a science. So you'll need to work with a lab coordinator or a lab assistant to find settings and contrast levels that will give you the results you're looking for.
One final task we want to do is add some lettering to our project. Over in the vertical toolbar at the left of the screen, select Text. Your cursor will change to an I with a T inside it. Click where you want the text to go. A pop-up will open and offer you a choice of text types. Choose True Type. Most fonts will work, but if it fails to preview, you'll need to select a different font. Type your text into the large white text box. It will be previewed in a standard font. Size can be set at the bottom. At the upper left, you can adjust horizontal stretch, spacing between characters, and spacing between lines. We don't use the enable variable text option below these controls. Once you're satisfied with what you've written, click OK. Your text will be previewed on the virtual cutting board in the position, size, and font that you've chosen. It is an entity, so it can be repositioned, rotated, or stretched the same as any other entity. There will also be a new line in your layer control spreadsheet. You may want to set the writing to a unique color, and you will definitely want to make sure that the scan or cut settings and parameters are adjusted to how you want them.
So now let's think about getting this ready to print. We know that the laser will start at the green square and work to the left and down from there. What we don't know yet is that, to the laser, this green square is the job origin. When a laser cut file is about to be run, the laser head is positioned by the operator, using cursors to drive the axes motors to an appropriate starting position, and then a button labeled origin is pushed on the laser control panel. This sets the origin for that job to the position the laser head is in when the button is pushed. Within a laser cut/engrave file, this will correspond to the green square. As such, we're going to want to look at the piece of wood or plastic we're going to cut our file from and select a starting point origin that makes the most efficient use of that wood. If we've got several parts, we'll want to lay them out on our virtual cutting bed to use the materials as efficiently as possible. In fact, that task is best done on DesignCAD when it's available and it can easily create the XF file where the parts are mated together to share cuts instead of duplicating cuts of the same shape on two separate parts. Layout is where we will use controls like rotate and mirror to make parts fit or control what side of the wood faces outward in the final product. Once you are satisfied, use the preview tool to run a simulation or at least find out how long the job will take. You can also toggle on the show path control to see if things could be positioned more efficiently in terms of laser head movements when it's not cutting or engraving. Efficiency is not super important in the Science Maker Lab other than minimizing wastage of wood. However, if we're going to do a production run, careful placement and setting up files to share cut lines wherever possible can save significant amounts of laser time, leading to much lower production costs.
Once we're set on our layout, we can close the preview and we're ready to export. We'll insert a dedicated USB stick into one of our USB ports. Click Save to U file. When prompted, we'll route the file to the parent directory of the USB stick. Nothing will appear to be happening. Be patient, it actually takes a minute to write the file and save it. It can be a few minutes if there is a large graphic involved. Once it's done, we get a pop-up with a triangle with an exclamation mark in it and some gibberish beside it. Don't be alarmed, you didn't break anything. The language options on this software are English and several Far Eastern languages that don't use the Roman alphabet. If you accidentally sent the language to something other than English, every text digit on the software will be in this winding symbol font. Windows is trying to match the characters used by the coders, but since we don't have Far Eastern characters loaded on our computer, it goes with what it thinks is the font that looks the most similar. Somehow, even in the English version, this happens in this text box. It just means success, or done, or saved. This software has more than its share of quirks, but it works very well for what we use it for, despite these flaws.
When we head for the laser cutter, we tend to leave the software open in case something fails, and we need to modify the cut file to try again. If someone else needs the computer or you're going to be cutting on a different day, you can close the RDWorks software and you'll be offered the option File to be modified, save or not. This interesting grammar just means that do you want to save a copy in the RDWorks native file format, which would allow you to reopen the layout file and modify it. If you want to keep a copy, save it to your folder or the iDrive, and it's there if you need it. Well, that's it. We're actually now ready to safely eject the USB stick and head over to the laser cutter, but that's a subject for another video. Bye for now, and we'll see you soon.